Welcome. Myself Yatrik Patel and I'm working as scientist in Information Library Network Center under EPG Pathshala. In ICT paper, we are going to study about cloud computing. Now, see, cloud is not a new term. Cloud, in fact, evolved with history of internet itself. Long back in 60s, JCR Licklider, who was also known as Lick, has given an idea of intergalactic computer network. This Lick was also responsible for enabling development of ARPANET, that is Advanced Research Projects Agency network in 1969. However, he didn't had any idea about how to implement the intergalactic network he was talking about. Other experts also attributed the concept of cloud computing to computer scientists. John McCarthy also proposed the idea of computation being delivered as public utility in 60s. In the past, computers were clustered together to form a single larger computer, and it was common industrial practice that allowed user to configure computers to talk with each other using standard protocol to balance the computational load across the machine. As a user, one need not care about which CPU ran the program, and the cluster management software ensured that the best CPU at that time was used to run the code. Then the concept called grid came into the picture with analogy to the electricity grid, where user could plug in into the grid and use a metered utility service. The same was applied for computing resources in case of grid computing, where user plug into grid of computers and pay for what he or she uses. Grid computing expands the technique of clustering, where multiple independent clusters act like a grid due to their nature of not being located in a single domain. However, the main bottleneck for moving cluster computing to grid computing was data residency. See, the computers in the clusters were usually physically connected to the disk holding the data, whereas in case of grid, the computational nodes could be situated anywhere in the world. It was fine having all the CPU power available, but the data on which the CPU performed its operation could be thousands of miles away, and this was causing a delay, or in technical terms it can say a latency between the data fetch and its execution. To avoid this bottleneck and to take grid further at a level of service, concept of cloud computing was introduced. As such, concept of grid computing was evolved to a service offered by data center. In short, the concept of cloud doesn't only involve computers, but it also encompasses the first cloud, which is around networking, or we can say it's around TCP/IP abstraction, and the second cloud around the documents, that is World Wide Web data abstraction. The currently emerging cloud abstracts infrastructure, complexities of server, applications, data, and heterogeneous platforms. If we go to theoretical definition, in generic term, cloud computing can be defined as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, for example, network, server, storage, application, and services that can be rapidly provisioned and released with minimal management of effort or service providers interaction. This was the definition given by NIST. Now, as far as user is concerned, a cloud is a service that satisfies all of the following conditions. The first one is it is delivered over a telecommunication network. User place reliance on the service for data access and data processing. The data is always under legal control of user. Some of the resources on which service depends are virtualized so that the user has no technical need to be aware as to on which applications are running on which server they are running, nor where the hosting device is located. The service is acquired under a relatively flexible contractual agreement. The fundamental elements of cloud computing can be categorized as primary and secondary elements. In primary element, one can consider virtualization, grid technology, service oriented architecture, distributed computing, broadband networks, browser as a platform, free and open source software. Whereas on secondary side, we have automatic system, Web 2.0, web application frameworks, and service level agreement. The conceptual model of cloud promotes availability of the resources, and it's composed of 5 essential characteristics, 3 service model and 4 deployment models. Now let us see essential characteristics of the cloud. As per definition of cloud computing by National Institute of Standards and Technology, let us have a look at 5 essential characteristics, that is on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Now let's consider on-demand self-service. That means the automated response by the server to direct request by the client. Cloud services such as emails, applications, database, storage, computing, network, or server service can be provided without requiring human interaction with each service provider. Cloud service providers that offers on-demand self-service includes Amazon Web Service, Microsoft, Google, IBM, as well as Salesforce.com. It is just like if you want to open an email account on the service provider, just log on to his site and create your account. That's on-demand self-service. The second aspect is, or second characteristics is broad network access. That is, one can use the services from anywhere using any devices. Cloud deliverables are available over the network and access through standard mechanisms that promotes use by heterogeneous thin or thick clients platforms. Cloud deliverables are available over the network and access through standard mechanisms that promote use by heterogeneous thin or thick client platforms such as smartphone, tablet, laptop, and desktop PCs. Then the resource pooling, that is, the provider allocates the resources according to the demand rather than assigning resources to particular client. The provider's computing resources are pooled together to serve multiple clients using multi-tenant model, with different physical and virtual resources dynamically assigned and reassigned according to client's demand. This resource includes, among others, storage, processing, memory, network bandwidth, virtual machines, etc. This characteristics also gives a degree of location independence in where the clients generally has no control or knowledge over the exact location of the provided resources, but may be able to specify the location at a higher level of abstraction, that is a country, state or regional data center. Rapid elasticity, that is resources are scalable according to demand. Usage of resources in cloud services can be rapidly and elastically provisioned, which can also done automatically to quickly scale out and rapidly release to quickly scale in. The capabilities available for provisioning often appear to be unlimited to the consumer and can be purchased in any quantity at any time. Measured service, that is also an important characteristic wherein each resource usage is metered. Cloud computing resources usage can be measured, controlled and reported, providing transparency of the both, that is provider and consumer of utilized service. Cloud computing service use a metering capability which enables to control and optimize the resources. This implies that just like any other utility service, IT services are charged per usage metrics, that is pay per use. Now let us have a look at cloud service models. Cloud service providers offers their services according to several fundamental models, that is infrastructure as a service, IaaS, platform as a service, that is PaaS, and software as a service, that is SaaS, where IaaS, that is infrastructure as a service, is the most basic and each higher model abstracts from the details of the lower models. Infrastructure as a service. It is the capability provided to the user to enable processing, storage, network and other fundamental computing resources where the user is able to deploy and run arbitrary software which can include operating system and applications over it. The user does not manage or control underlying cloud infrastructure but has control over operating system, storage, deployed application and possibly limited control of selected networking components. Whereas in platform as a service, it provides an application platform or middleware as a service on which developers can build and deploy custom applications. Common solution provided in this tier ranges from APIs and tools to database and business process management system to security integration, allowing developers to build application and run them on the infrastructure that cloud vendor owns and maintains. Software as a service. The applications are accessible from various client devices through a client interface such as web browser. You all are familiar with web-based email. The user does not manage or control the underlying cloud infrastructure including network, servers, operating system, storage or even individual application capability, with the possible exception of limited user specific application configuration settings. Apart from these three basic service model, network as a service, that is NAAS, and communication as a service, that is CAAS, were officially included by ITU, that is International Telecommunication Union, as a part of basic cloud computing models, recognized service categories of telecommunication centric cloud ecosystem. Now let's have a look at cloud deployment models. As shown in the figure, you can have public cloud, private cloud, community cloud, as well as hybrid cloud. A public cloud is publicly accessible cloud environment owned by a third-party cloud provider. The deployment of a public cloud computing system is having two major characteristics. The first one is public availability of the cloud service offering, and the other is public network that is used to communicate with cloud service. The cloud service and cloud resources are procured from very large resource pools that are shared by all end users. If a cloud provider runs several data centers, for instance, resources can be assigned in such a way that load is uniformly distributed between all centers. Generally, public cloud service providers like Amazon AWS, that is Amazon Web Service, Microsoft, and Google own and operate the infrastructure and offer access only via internet. Whereas the private cloud is infrastructure operated solely for a single organization, whether managed internally or by third party, and may be hosted internally or externally. Self-run cloud infrastructures are generally very costly and capital intensive. They have a significant physical footprint requiring allocation of space, hardware, and environment control. These assets have to be refreshed periodically, resulting in additional capital expenditures. Generally, private clouds are not preferred because users still have to buy, build, and manage them. So, complexities are involved. Community cloud. Community cloud is similar to a public cloud except that its access is limited to a specific community of cloud consumer. In this delivery model, cloud infrastructure is being shared between several organizations from a specific community with common objectives. It can be managed internally or by third party and hosted internally and externally. The costs are spread over few users than a public cloud, still more than private cloud. So only some of the cost saving potential of cloud computing are realized. Hybrid cloud. A hybrid cloud is a cloud environment of two or more different cloud deployment models. Hybrid cloud offers the benefit of multiple deployment models. Hybrid cloud can also mean the ability to connect, co-location, manage, and or dedicated service with cloud resources. A hybrid cloud service can be defined as a cloud service that is composed of combination of private, public, and community cloud services offered through different service providers. A hybrid cloud service crosses isolation and provider boundaries so that it cannot be simply put in one category of public, private, or community cloud services. It allows one to extend either the capacity or the capability of a cloud service by aggregation, integration, or customization with another cloud service. So, in this figure, you can see the delivery models, service models, and essential characteristics of the cloud. By using cloud, a library services can be made online without worrying about correct version of the platform or the underlying technology. It also gives facility to induce new application quickly without having to focus on identifying available server space or configuration, and IT based library services can be delivered much more quickly than when using locally based hardware or software. Library can make choices about the allocation of resources and to offer better services than would be possible if relying on in-house solution. Thank you.